dear professors and all the dear delegates. I am Swati Parashar and I am going to present my research work known as TBHP assisted catalytic oxidation of styrene using copper shift base intercalated in layered double hydroxides. And thank you for giving me this opportunity to present me here. These are the contents. First one is the research highlight, then introduction, synthesis of catalyst, characterization of catalyst, catalytic activity, optimization of reaction condition, recycling, conclusions and references. Research highlights. The synthesis of my catalyst has been done under moderate conditions. Work has been done using non-poisonous transition metal, that is copper, and highly stable heterogeneous catalyst under my reaction condition. The conversion of styrene is 66.19% under optimized conditions, and my catalyst has been recycled for the 10 times without any significant loss of catalytic activity. Introduction. The process of oxidation is an important procedure, and especially the oxidation of styrene plays an important role as it gives styrene oxide, benzaldehyde and benzoic acid as the product, where benzaldehyde can be used in the production of pharmaceuticals, agrochemicals, resin additives, perfumes, etc. While styrene oxide can be used as an epoxy resin, surface coating, perfumes, bulk chemicals, and if we talk about benzoic acid, then it can be used in its salt form in drug and food industries. In this field, shift bases are of great importance. Initially, they were used in their homogeneous form, but it suffers from non-reusability, contamination of product and separation of product, and hence concept of heterogenization comes in the community of this field. Now for heterogenization of the copper shift base complexes, various supports has been used like alumina, clay, polymer, etc. Now I am representing my work here, which is styrene oxidation by copper shift base complex intercalated in layered double hydroxide known as LDH SALBaCu. The catalytic activity of it has been used for the oxidation of styrene. This is the synthesis of catalyst, which has been done in 3 steps. First step is the synthesis of support, that is LDH NH2C6H5COO, which is made by zinc nitrate and aluminum nitrate with alkaline solution of 4-amino-benzoic acid. Then when it is treated with salicylaldehyde in the methanolic solution for the 4 hours, then we get the product which is known as LDH SALBa, which is a ligand and it is in yellow colored. And when it is treated with copper acetate, then after 4 hours of refluxing, we get a brown colored solid material which is known as LDH SALBaCu, which is my heterogeneous catalyst. Now these are the characterization of the catalyst, in which metal content has been found out by ICP AES analysis, and it is found to be 6.53. The basal spacing is 15.66 in my support, while in my catalyst it is 20.36 angstrom. And if we talk about the elemental analysis, then these are the data of elemental analysis. If we talk about BT surface area, then the support is 10.15 meters square per gram of surface area, which increases to 18.84 in my catalyst. This is the XRD pattern. First one is of support and the second one is of copper. It is having spacing 15.36 angstrom along 003 of plane, and it increases to 20.34 angstrom in catalyst. This is the schematic diagram of LDH structure, in which this copper complex is inserted into the layer of this layered material, that is layered double hydroxide, and the increasing of these spacing indicates that there is successful intercalation of this complex inside the layer of this support. This is the FTIR spectra, which shows some peaks. The peaks in between the 310 to 3600 is due to the OH stretching peaks, and the one more important peak at 1615 is due to the imine peak C double bond N, which occurs in our ligand, and the peaks between 750 and 650 is due to the metal oxygen and metal nitrogen stretching. These are the same images of it, which show the clearly flake-like structure, and there is no much difference in between the support and the catalyst, which show that the properties of support remain intact in the catalyst also. These are the ADEX spectra, which show clearly the presence of carbon, oxygen, zinc, aluminium, oxygen, nitrogen, and in catalyst it is showing copper also. These are the TGA curve. It shows the thermal stability of my catalyst, and there are some falls, two major falls. One fall in between 25 degrees centigrade to 250 degrees centigrade is due to the loss of absorbed water, and the second fall indicate the degradation of the brucite layer. This is the catalytic activity. The catalyst is LDH, SAL, BaCu. Styrene has been taken 5 millimole, and TBHP, which is oxidant in my case, has been taken as 10 millimole. So 1:2 molar ratio has been studied, and the reaction time was 5 hours while the temperature is 80 degrees centigrade. This is the scheme when styrene is treated with this catalyst in the presence of oxidant. Then we get styrene oxide, benzaldehyde, and benzoic acid. These are the optimization. Optimization has been done to calculate the some optimum conditions, and for it catalyst concentration, molar ratio, and temperature has been studied. First one is the effect of oxidant. When the ratio is increased from 1:1 to 1:2, the conversion increases, and when it goes to 1:3, then conversion decreases. Hence 1:2 has been taken as an optimum molar ratio. Now the effect of catalyst concentration. When catalyst is 50 milligram and it increases to 75 milligram, then it gives conversion around 65%. And when it increases to 100 mg, then there is no much difference in between the conversion, and hence 75 mg has been taken as the optimum catalyst concentration. Now the effect of temperature, it is clearly indicated that when in temperature increases from 70 to 80 degrees centigrade, then conversion increases, but there is no any marked change when we increase the temperature to 90 degrees centigrade. Hence 80 degrees centigrade has been taken for optimum. Now recycling of catalyst, this is the beauty of my catalyst. It can be recycled for the 10 times without significant loss. In first cycle it has 66.19% conversion, which decreases to 56% in the 10th cycle, which is not so much of difference, and it is the beauty of heterogeneous catalyst also. Now conclusions. LDH intercalated copper shift base complex has been synthesized by intercalation method. It is characterized by XRD, FTIR, ICP, AES, SEM, EREX, BET surface area, etc. Its catalytic performance has been studied for the oxidation of styrene, in which 66.19% conversion is obtained. The three products are obtained, which are styrene oxide, benzaldehyde, and benzoic acid, in which benzaldehyde is the major product. Now, the catalyst has been recycled for the 10 times, which proves it to be fantastic in the sense of stability, activity, and reusability. These are the references. Acknowledgement. I am thankful to Almighty God, my parents, and my supervisor, Dr. Savita Khare, and also the organizers of ISCA 2017 for giving me opportunity. Head School of Chemical Sciences, UGC DAE Consortium, SEF, IIT Mumbai, and STIC for providing analytical facilities. Thank you.
Thank you, Swati, for remaining within time. Now questions are invited first from judges and then from the audience. Yeah.
Sir, by using various homogeneous catalysts also we can oxidize the styrene.
Any two examples other than your method?
Sir, first one is by using homogeneous copper catalyst we can oxidize it, and also styrene is very reactive, so it can be oxidized at such an open air also. But it takes too much of time when it is converted to styrene oxide, benzaldehyde, and benzoic acid.
Why do you think that there is a need for another method? It's very good that you developed a new method,
Yeah.
but why do you think there is another need when we have so many methods? We have ruthenium, we can use ruthenium, we can use MCPBA, we can use many methods. Why do you think there is a need for one more method?
Sir, we can do it with ruthenium also, but it is costly, and copper is not so much of costly. So we can take for the copper. And also MCPBA was tested in my case, but MCPBA didn't give good result. Even I tested H2O2 molecular oxygen also, but the good results with TBHP, so I carried my research work with the TBHP only.
So question from audience, if anyone want to ask anything. Yeah.
And the best thing for any of the catalytic process is the catalyst must be regenerated at the end of the reaction.
Yeah.
Did you test that your catalyst has been regenerated? Because you are trying to have the catalytic cycle, how many times it can be used. But I just want to know that did you try that catalyst can be regenerated at the end of the reaction?
Yeah, sir, we have tried it, and the reused catalyst was also undergone several characterization like XRD and BET surface area and ICP-AES, in which ICP-AES it gave 4% of copper, which decreased from 6.39 to 4, means it remains its quality after 10 cycles also. Even XRD is the same for reused catalyst and the fresh catalyst. Also, if we talk about the BET surface area, then there is no any so much of difference in between the surface area of fresh and reused catalyst.
What is the full form of BET? Very simple.
Brunner, Emmett and Taylor.
Okay, thank you.
Surface area.
Thanks.
Yeah. One quick question you can make.
What is the amount of catalyst in your oxidation process?
So 75 mg. We have tried 3 amounts.
75 mg
mg
to
of
convert how much? For converting styrene, how much amount of styrene is converted using 75 milligram of
5 millimoles of styrene has been converted by using 75 mg of catalyst.
One suggestion, surface area of your catalyst is very poor.
Yeah.
So you have to explore some possibility just to enhance the surface area, and accordingly the reactivity will increase.
Yeah.
And are there any chances of reversibility of the reaction, because when moisture exposure is much high, even in weather change also, in humid conditions and less humid conditions, because you are working on the SIP base, so that there are
Yeah, sure.
possibility of, you can think over and can aid such modification in your system.
Okay.
So thank you, Swati.
Thank you so much.
And now next
you.
presentation. Kanika Solanki. Kanika is from PG Department of Chemistry, Government Dungar College, and MGS University, Bikaner, Rajasthan. Okay, your 10 minutes starts now.
Okay, good afternoon all of you. My title is Application of Calotropis procera based chelating resins for the pre-concentration and estimation of iron, nickel and copper in milk, cereals and vegetable oils. Proposal and hypothesis. Preparation of chelating resins from the wasteland desert plant Calotropis procera, that is commonly known as ARC or ACRA. The characterization, investigation of various parameters on the absorption of metal ions by batch ion or column method. Development of methods of trace estimation of ferrous, nickel and copper ions, and the application of methods in the commercial samples of milk, cereals and vegetable oils. Abstract. 3 novel chelating resins, that is modified Calotropis procera dry latex, modified Calotropis procera bark and modified Calotropis procera root, have been prepared by the different parts of the Calotropis procera, that is latex, bark and root. The method of preparation of resins and their analytical prospects are also delineated in my research work. The effects of various parameters on the absorption of metal ions has been evaluated by batch and column method. The method of trace estimation of ferrous, nickel and copper have been developed and successfully applied in their estimation in the samples of milk, cereals and vegetable oils. The general introduction and necessity of this research work. Environmental monitoring of heavy metal ions plays the most significant role in ecological assessment and to understand the dissemination of pollutants. Heavy metal ions exhibit toxicity even at low concentration, so that their accurate estimation is essential. Copper, zinc, bismuth, nickel, selenium, etc. are very important for living organisms. They can be vital or toxic for the concerned organism depending on their concentration. The accurate analysis of metal ion is one of the most concerned area of the research. In analytical chemistry, one of the most difficult and complicated tasks is the accurate analysis of metal ion, especially at trace level, as there is meticulous requisite of versatility, specificity, sensitivity, and accuracy. Present scenario. Today's various techniques are available for the direct determination of trace metal ions. The solid phase extraction of metal ion has the clinched swift acceptance over other methods owing to several advantages. Now, what are the chelating resins? A group of materials having chelating or complexing group embodied on their surface are known as chelating resins. For example, Dovex, Chelax, Sinex, Ambalite, cellulose, starch, etc. Now, for specific and selective absorption, above material can be used as support matrix. For example, iminosalicylate silica, which is the chemical modification of a resin surface, that is silica, with salicyl aldehyde or orthovanillin. Now, as you can see in the picture, the hydroxy group present on the surface of the silica has been anchored by the 3-aminopropyl trimethoxysilane. So, this anchored ligand or pennant ligand can be used for the selective absorption. Application and advantage of chelating resins. Extraction of metal ions without using toxic chlorinated organic solvent, high capability of binding metals, high selectivity, thermal stability. The advantage of green resins and disadvantage of green resins and disadvantage of chelating resins and the need of green resins. Method of preparation of many, almost all, involves the use of toxic solvents. The synthesis procedure is tedious and time consuming, and the preparation of, for example, the preparation of immobilized silica requires 72 hours. These methods are very expensive, and in many cases regeneration is not possible. These are the techniques which we have used in our research work, that is spectroscopy and chromatography. Now, synthesis of modified Calotropis procera resins, it includes following steps: identification and collection of plant material, preparation of dried powdered material from the different part of Calotropis procera, cyanogen bromide activation of powdered Calotropis procera, immobilization of amino alkyl group on the activated powdered Calotropis procera, synthesis of modified Calotropis procera. These are the pictures: plant, collection of the sample, and the prepared resin. These are schematic representation of various reactions, that is cyanogen bromide activation, immobilization of aminoethane, conversion of aminoethane into N-salicyl aminoethyl Calotropis procera dyed latex. Now, the table presents the characteristic IR band of aminoethyl and modified Calotropis procera latex bark and root. For the trace estimation of metal ions, we have used batch and column method. The optimization of working condition. For the optimization of absorption time, we have used batch method, and the supernatant solution was separated off at different time intervals for between 2 to 20 minutes, and the solution was determined by the means of AAS. As you can see in the table, for equilibrium absorption time for ferrous and nickel is 8, and for copper it is 10 minutes. The absorption isotherm, again batch method is used, 6 sets have been prepared between the range of concentration, pH was maintained, and supernatant solution was determined by the AAS. Absorption isotherm values are also given. Now, this is the graphical representation of absorption isotherm of ferrous, nickel, and copper. The effect of pH. To investigate the effect of pH, we used column method, and the flow rate was maintained 2 ml per minute, and elution was carried out by 0.1 normal HNO3, and the estimation by AAS. The effect of pH, the optimum pH for the investigation of ferrous is 6.5, for copper 7.0, and nickel 6.0. These are the graphical representation of data. The effect of type and the amount of immobilized resins. For this, we have used column method, 3 different immobilized resins, that is Calotropis procera, bark, root, and dry latex. The particular amount of the latex, that is from 0.02 to 0.16 gram of modified resins. Flow rate was 2 ml per minute, and elution was carried out by 0.1 normal HNO3. As you can see in the table, the Calotropis procera dry latex is better as compared to modified bark and root. In the case of Calotropis procera dry latex, we are able to recover 100% metal ions with using 0.08 gram of the resin. This is the graphical representation of the data. Effect of temperature. To investigate the effect of temperature, we have used a batch technique. The solution were kept at constant temperature between 25 degrees centigrade to 45 degrees centigrade in a thermostat. Supernatant solution was separated off and determined by the means of pH. The absorption increases up to 35 degrees centigrade, it becomes constant up to 45 degrees centigrade, and then it decreases marginally. The effect of flow rate was also investigated by the column method. The most suitable flow rate found is 2 ml per minute. The effect of electrolyte had no effect on the absorption of metal ions by the immobilized resin. The pre-concentration and recovery of metals, as you can see, we could able to recover 98.7% of Fe, 97.5 of copper, and 98.4 of nickel. The analytical applications of immobilized resin, by applying using these resins, we could able to determine the iron in milk. These are the data. We could able to determine the irons in medicines tablets. These are the data from cereals, and determination of nickel in partially hydrogenated vegetable oils. These are the tabular representation of the data, and the determination of nickel in hydrogenated vegetable oils, that is ghee. These are the data. Now conclusion. Immobilized resin is quite effective in the pre-concentration of ferrous, nickel and copper. The working conditions are easy to manipulate and the methods are very selective. Iron and nickel have been successfully estimated in various commercial samples. The immobilized resin can be used and the method is green. No chlorinated solvent are needed for the extraction of these metal ions. The acknowledgement, Green Chemist Research Center, Government Dunga College, Bikaner, College of Engineering and Technology, Bikaner, and UGC for financial assistance. Thank you so much.
Questions from judges first.
You use acetate and borate buffer.
Yeah.
Any other buffer can be used for this process?
We haven't tried for any other buffer. We just, because we have to maintain the range between this, and these buffer are very easily available in our lab, so we have used
Your range is 6 to 7?
6 to 8.
6 to 8.
Yeah.
Do you ever think what will be the condition of these metal ions at this pH?
What?
Iron, copper. In what form they are present in your estimation?
In plus to oxidation state,
No, the pH is 6 to 8. In what form these metal ions will be present in your estimation?
I assumed during my research, but I assumed that these metal ions are present in oxidation state, that that is Fe+2, copper +2, and nickel +2.
In which salt form?
Which salt we have used? For copper we have used copper sulfate. For nickel we have used nickel chloride.
I just have a little different question. You see, you mentioned the spectroscopies that you used, and you
Yeah.
have written magnetic resonance spectroscopy.
Yeah,
What do we call it in short?
magnetic resonance MRS.
Is it the normally that we call this technique? My question is from a different angle. You see, normally I think that we call it NMR, isn't it?
Yeah, but
Right?
we haven't because we are using for only the ligands,
Yeah.
not for the entire material we have designed. So we are only use the magnetic resonance. We only put the name magnetic resonance spectroscopy, not the NMR, because NMR is we can use NMR for specifically hydrogens and something like that. So we haven't put that in our study.
Fine.
Yeah.
Okay. First, for any analytical chemist, it is very important to find out the detection limit and limit of quantification. In whole of your presentation, I did not see. Did you really determine the detection limit of your chelating agent and limit of quantification?
Yeah, for the detection limits for the estimation of metal ions. Yeah, as you can see in the data that we could able to determined in the ppm range varied from 0.2 to 0.4, and it depends on the metal ion concentration basically.
Yes, there should be 3 detection limit and 3 limit of
Yeah.
quantification.
Yeah.
But what you have presented is only the range, and that's what you are talking. Detection limit should be different than the range.
Okay, thank you, sir.
Okay, thank you.
How can you conclude that there is no effect of ionic system on the absorption? Have you mentioned?
Yeah, we have when during the investigation we have used metal ion electrolytes in to investigate the matrix effect, but we didn't identify any significant changes during the absorption of metal ion.
What type of interactions are involved in this interaction process, adsorption process?
In they are the formation of chelating ring, and the von der Waals absorption takes place during the absorption.
Anybody? Yeah.
Thank you.
You talked about 100% recovery in most of the systems.
In the case of modified calotropist process at dry latex.
Yeah.
Yeah.
But I doubt that you seriously observed analytical estimation accordingly, because that is very difficult. You are working over the PS628. So hydroxyl concentration will be sufficient, and AS is a very sensitive technique that way. But you have to check your results here. This is a suggestion to you.
Thank you.
Yeah, so thank you. And Nanotechnology, Institute of Technical Education, Anusandhan University, Bhubaneswar.
Respected sectional president sir, and all the professors present here, delegates and my friends. The title of my presentation topic is Materials Designed for Energy and Environmental Application. I have little bit changed my title because I want to show some of my previous results. Before going to my topic, let me discuss about solar energy. According to the statistics that is reported by International Energy Agency, the world energy consumption in a year is actually, sir, I will come to, sir, it is just I just brought this topic little bit because I want to show some of my previous results. No, sir. Yes, sir. I will go, sir. No problem. I will go. Before going to my topic, let me discuss regarding solar energy. The world energy consumption in a year is equivalent to 16 terawatt, but the solar energy that is really absorbed on the surface of the earth is around 89 picowatt. So this result suggested that we have lost 5,000 times of solar energy in each year. So if we want to utilize solar energy, this is the one of the efficient way. That is, the sun is abundantly available, and the water is the abundant source in the universe. So utilizing a particular photocatalyst, we can efficiently produce hydrogen gas. This is the basic principle behind photocatalytic water splitting. When light of sufficient energy is fall on a semiconductor nanoparticles, there is excitation of electron from the valence band to the conduction band, and the valence band side it oxidizes water to O2 gas, and the conduction band the free electron reduces proton to H2 gas. But the most important factor is here is recombination, because the electron that is in the excited state, it is quite unstable and it tend to recombine with the whole, and this recombination process always decreases the efficiency of a photocatalyst. So in order to develop efficient photocatalyst, we must have to consider these points like absorption efficiency, charge separation efficiency, charge transfer efficiency, and charge collection or carrier efficiency. So the mone efficiency loss is mostly due to the electron hole recombination. So how to improve the charge transfer, the light absorption efficiency. In this regard, I have developed a material that is a nitrogen doped gallium zinc mesoxide. The gallium zinc mesoxide is originally active under UV light, but when I dope with nitrogen, the optical absorption is clearly shifted towards the visible region. This paper was published in Journal of Material Chemistry, and I have also successful in modifying the surface structure of the material. I have got various morphology, and this material showed a high the very good activity towards hydrogen evolution. So, and then the next question is how to increase the charge separation efficiency. So, modifying a heterojunction, giving importance to heterojunction photocatalyst, we can improve the charge separation efficiency. In this regard, I have developed this material, that is I have modified zinc oxide with indium oxide, and this material is reported in Journal of Material Chemistry. And this material also gives very good hydrogen evolution under visual light irradiation. This is also another material, and this paper has been published in Inorganic Chemistry. And then how to improve the charge transfer efficiency. So, designing a 1D or the low D material, we can improve the charge transfer efficiency, because in a 1D material whole transport with a short diffusion distance, the light absorption with a long attenuation length, and the vectorial electron flow through axial direction. So, in this regard, I have developed this material, and this material is published in Dalton Transaction in the year 2012. Then how to improve the charge collection or the charge collection or the reaction efficiency. So, in this regard, we can deposit some co-catalyst, or also we can utilize some charge transporter like graphene oxide. In this regard, this paper has been published in various good impact journals. So, what is graphite carbon nitride? Whatever material I have discussed, all are metallic material. Then that I have produced during my PhD study. But now I am focusing on the graphite carbon nitride. It is a high surface area material. It can split also water molecule, and it is a different carbon source. But the most important thing is it is a non-metallic photocatalyst. So, in this regard, I have developed this material, the highly active graphite carbon nitride. Generally, it is prepared by utilizing a urea source or melamine source. So, but in this paper, I have just mixed the unimolar ratio of urea and melamine, and I have successfully modified the surface structure, the internal structure of the graphite carbon nitride, where I have mixed the melamine and urea in unimolar ratio. The two-dimensional layer of graphite carbon nitride is well separated, and it shows very high activity than the material prepared from only urea and the melamine source. And this is the work that I have submitted to Indian Science Congress. This is one-step synthesis of graphite carbon nitride powder photocatalyst and thin film. Actually, most of the work that I have reported by taking the graphite carbon nitride regarding powder photocatalyst, but it is very difficult to synthesize the thin film, because its conductivity is very low. So here I have adapted some unique technique where I can synthesize in one step powder photocatalyst as well as the thin film. So I have taken melamine, that is the carbon that source containing the carbon and nitrogen in a crucible, and I put a FTO plate. The FTO surface it is the conductive surface, so it is faced towards the sample. When I heated it for 550 degrees centigrade for 2 hours, I can successfully synthesize thin film only a single step. So I have characterized this method by XRD, and the XRD technique showed that this material is successfully prepared by taking the powder and as well as also the thin film. And this 002 peak is due to the interlayer distance in the graphite carbon nitride thin film, and this the 100 plane is due to the hole to hole distance in the trigen unit plane of the graphite carbon nitride. This is a UV visible DRS study of the powder as well as thin film. Both the material could able to absorb the visible light irradiation. And this is the FTIR spectra. In the FTIR spectra, and the all kind of bonding like the bonding due to the trigen units, and the carbon nitrogen single bond and the carbon nitrogen double bond, all the bonding are confirmed from the FTIR spectra. And but in case of powder, I found that there is a broad absorption spectra at around 3000 to 3500. It is mostly due to the surface absorbed water molecule. But in case of thin film, although this peak is there, but it is very less. In case of same, when I studied the surface morphology of the material, I found that the material that is obtained in the powder form, it is quite agglomerated, but the material that I obtained in the thin film, it is clearly to 2D like structure. So if I consider how can I improve the surface structure, it is one of the best material where we can easily modify the surface structure of the material. In the XPS study, I found that both in case of thin film I found that this material well satisfies all the conditions on all the electronic environment, the carbon-carbon bonding, the carbon-nitrogen bonding, and the nitrogen-carbon bonding all are confirmed from the XPS spectra. And from the photocurrent study, I found that the material I prepared in the powder form, it could able to generate 0.02 microampere current, but when the film I obtained in a single step method, it gives around 25 times higher photocurrent than that of than the material obtained in the powder form. And this is the unique study of my material. Until to date, whatever literature reported, this is the highest ever photocurrent obtained by taking the G thin film that I prepared in a single step. So, but although I have prepared in a single step, but further surface modification required to improve the photoelectrochemical properties of film, because for fish application this much current is not sufficient. When I tested the powder catalyst towards photochemical activity, it retains its own activity. It could able to generate 17 micron hydrogen gas in 3 hours of light radiation, and also could able to degrade 100% of 100 ppm Roentgen solution. So putting it all together, in order to design efficient photocatalyst, we have to look towards heterojunction, towards all the nature of a photocatalyst. We have to look go to heterojunction. Also, we have to put some conductive scaffold like graphene, also utilizing co-catalyst doping. So, to develop a efficient photocatalyst for industrialization of the process, we have to look all the points. So now we are at the 5% efficiency. So, yes, creative material design is a new vehicle to the goals, and it is my final conclusion. These are some of my publications, and within this year I have published 30 articles with citation factor 981, FOH index 16, and ITN is 26. And these are ongoing projects. Now I one project as principal investigator, and three projects are co-principal investigator. Finally, I thanks to my Professor Poidas group, he is my supervisor. Under him I have done most of the work, and thanks a lot for your nice hearing.
Okay, questions from judges, please.
You said the activity of thin film is much higher in comparison to the thicker one.
Powder one.
Yes. Broader one.
Yes.
Do you ever think what would be the reason?
Actually, sir, in case of two-step preparation, so whether I prepare the powder, then I prepare the film, the surface contact between the graphite carbonate and the thin film is less. But when the reaction triggers directly, and here the surface reaction is high, and all about the photocatalytic process is surface reaction. So I think that is the possible reason for the highest activity.
Well, questions from the audience can also come.
Is there a possibility that you can use nanomaterials, nanocomposites are known?
Yes, yes,
Zinc
yes.
and zinc titanium, they do a lot of auto oxidation for demineralization of water.
Sir, I could not able to get your point.
Demineralization of water and elimination of water,
Demineralization
removing pollution, water pollution.
Okay, okay.
To
Actually,
get pot water, they use a lot of this auto oxidation process recently, and they have also the nanocomposites.
Yes.
Zinc oxide, titanium, then you can
Yes,
modify
yes,
the
yes.
band gaps.
I have also worked on that.
But you mentioned about the solar energy,
Yes.
and you use any lamp for this?
I have not mentioned anywhere solar energy. I have used
In the beginning
300
you
watt
mentioned-
xenon lamp of that is lambda greater than 4 nanometer. Just I got up to 4
In the
nanometer.
beginning you mentioned about solar energy, I thought whether you are using sun rays
No,
for
no, that's
water
not-
oxidation,
actually-
not lamp.
actually the
You are
target-
using the solar energy.
Please listen. The target of our research is to utilize the solar energy, because without utilizing solar energy, this
Okay.
process cannot be industrialized. So, how to improve the absorption property of the material, it is very important, because the first work is reported by Fukushima Hyundai 1972, and that process the efficiency is 0.1%. Now by 2010 we are achieving up to 5%.
Powder, thin films, maybe nanomaterials will be helpful.
Yes, no, yes, sir, yes, sir. Thank you.
Were you able to find really some real application for photo-electrochemical application? That's what your title was.
Yes,
So have you really applied?
yeah, actually, sir, I have.
Because I did not see any application that you presented, but the title says the presentation. Photo-electrical application.
Actually, sir, whatever in the paper, just I focus regarding the IV curve that is shows the 25 times higher than the powder photocatalyst, and the detailed surface modification study is now going on. Because without surface modification, at first we have to improve the photoelectrochemical property of this material. Now in my present research, I have modified with CoPI, that is cobalt phosphate oxidation co-catalyst. Now I have achieved up to 50 microampere of current. And as that is, I have not sent to the ISCA, I have to present only this one.
So still you have to reach to application.
Yes.
But your title says
Actually, in the
application. Okay, thank you. Good luck.
Thank you, sir.
Any more questions? Victor? Yeah.
Hello sir, excuse me. Actually I believe that it is an application because
Yes.
you're producing current now.
Yes.
I think it is the application
Yes,
part
thank
of
you,
it.
sir.
Thank you very
Thank
much.
you. Thank you.
And wish you all the best. It
Thank
is
you.
novel sir, really.
Thank you, sir.
Right sir.
What is your date of birth?
Sir?
Date of birth?
Sir, my date was 8th April 1985. This is my last.
Yeah. That's why I asked as per the iska naam. So thank you, Dr. Martha, for the nice presentation.
Thank you, sir.
That you have made. Again to all the young presenters. I think I hand over after No. Sectional committee. नहीं आप हाँ session is we are taking a break here now, that is a tea break, and afterwards sectional committee. Is it?
We'll end this session, then we'll break for tea, then come back for
yes.
what is that session?
A sectional committee meeting we want to have,
Yes,
na?
yes.
So after that, after this break, those who are member of the chemical sciences, member in good standing only, they will be participating in the sectional meeting. That is the